All right, so hello everyone to the first meetup of 2016. I haven't completely committed to the date yet, so you'll see on the front desk there are still 2015 SF stickers because I'm in denial. All right, so tonight we're going to have a couple talks. I asked the audience if anybody would be interested in doing sort of the longer 10-minute slide talks, but turns out people want more than 2 weeks ahead of time to plan those. So we have talks being given by Pebblers who used to be a part of the community, so we're going to just count that this time. And then now you have more time to prepare lightning talks for February, and I have a bunch of those on the books. So this time we are going to have Brad talk about 3.x on Tintin, which we publicly refer to as Pebble Classic. He'll get to that. Then we're going to have John Barlow talk about the most basic intro to the Health API, which just got released in beta today. Then we're going to have John Garcia talk about time of my life living with Pebble. Then we're going to have Heiko do sort of a group discussion about Rocky.js. And if you have no idea what that is, it's very, very exciting if you like JavaScript. And then after that, we're going to do a bunch of community demos, but I'll take a break in between those and announce those later. After the community demos, and we're going to do a raffle. I have a black Pebble Time steel for people in the audience, one person in the audience, and then some rare Pebble pajamas that we dug out of a closet when we moved offices recently that I thought didn't exist, but they do, so you get a couple of them. All right, and without further ado, I will turn it over to Brad.
Thank you. Hi, everyone. So for those who haven't met me before, my name is Brad Murray, and I've worked for Pebble for about 3.5 years now. I joined during the first Kickstarter campaign. And pretty much the whole time I've been here, I've been doing firmware at Pebble. What I want to talk to you today about is called 3x on Tintin. That name probably needs a bit of unpacking. When we refer to 3x, we're talking about the 3.0 plus line of firmwares. It's our kind of third generation of firmware after the 1.0 kind of time in back in 2013, the 2.0 time in 2014 with the App Store, and then recently, last year when we launched Pebble Time, we went into 3.0 with Timeline and Infinite Apps and all that good stuff. The Tintin part, so internally we refer to the product that you know as Pebble Classic, or Pebble, or the OG Pebble, or AppLite, or so on. We internally have the code name for it as Tintin. So the project that I was working on is called 3x on Tintin because we're bringing that 3.x series of features and that firmware back to the Pebbles that we first manufactured in 2012. So just kind of an image of the timeline here. So in February of last year, we launched firmware 2.9, which was actually the first firmware before their second Kickstarter for Pebble Time, supported Pebble Steel. And then we pretty much switched gears entirely over to firmware 3.0 with the Kickstarter and launched that only for Pebble Time and Pebble Time Steel. And we kind of stranded our users back on firmware 2.9 for our Pebble and Pebble Steel users. And then ever since we launched that, the Pebble Time and the Pebble Time Steel, we've been working on bringing firmware 3.0 to absolutely everyone. And we recently did that with shipping firmware 3.8 to absolutely all of our products back in December. But in the meantime, there was about a 10-month gap where our old Pebble and Pebble Steel users didn't get any firmware updates, which is probably the longest gap by many times over since we've become Pebble, basically. So why do we do this? Why do we continue shipping firmware to these devices that we first started building and selling in 2012? The big thing is that it's because we've always done this. It's super important to us that when you buy a watch, that's not when we stop interacting with you. We continue to improve the software, change the experience, fix bugs, and basically rebuild everything like month over month, and we want to share that with everyone. The other thing that we're looking at this from is from the developer standpoint. So we wanted our developers to be able to build apps easily for the entire Pebble user base, whether it's color, whether it's black or white, whether it's round, whether it's square. And part of that means that the software that's running on all these devices is roughly uniform in terms of what APIs are available or how it works. So, but then if we're so dedicated to this, why did we stop in the first place? And the reasons for that are very largely technical. And this is kind of where the talk takes this wicked technical swing, where I'm going to go through why we stopped supporting Pebble and Pebble Steel in the first place, and all the work that we had to do in order to bring it back. So to understand this, starting out, you have to understand kind of our architecture a little bit. So there's 3 different types of storage on Pebble. There's our RAM, which is just like the RAM on your computer. It's used for storing the data that you manipulate while your watch is running. There's the storage flash, which is this big, slow chip that's hanging off on the side of the board that we use for storing fonts. We use for storing images, kind of static data that we want to display on the screen, and it tends to be very big, but this storage is kind of slow. And then the part that we're going to talk about most today is the system flash. So this is a piece of flash memory that's stored right in the microcontroller itself, and it actually stores the firmware itself. So whenever we ship you a firmware update and we write all our code and we compile it into this blob and ship it to you, that's where it gets installed to, and that's where it runs out of. So to put some numbers beside these things, for Pebble and Pebble Steel, the numbers are all the same. For Pebble Time and Pebble Time Steel and Pebble Time Round, the numbers are all the same. So there's kind of these two generations of product. And you can see for Pebble Time, all of the storage is roughly double. And the biggest thing, the biggest roadblock to us during this time was that system flash space. So when we were developing our software for Pebble Time, we ended up running up against that limit in order to enable all the new things that we wanted to enable for firmware 3.0. And we ended up basically creating a firmware that was too large to even fit on Pebble. And this is something that we monitored all the time. We knew that it was going to be a challenge. And early this year, we decided that it was going to be very hard for us to ship firmware for all of our platforms due to the growth in code size requirements. The funny thing is that this was not a new problem. So I'm not sure if you can read this all that well, but I decided to dig through my email today and kind of look through the code size history at Pebble. And actually, the first time that we ever ran out of code space was actually November 28th, 2012, according to my email. So before we even shipped 1.0, before we even shipped product to end users, we were running up against that 512 kilobyte limit. And it continued to be a constant challenge for us as we continued adding features and rewriting parts of the operating system. So I think this is really a testament to like kind of our long-term fight with this kind of issue, where when we started out in 2012, the feature set was much smaller than it was today, and only by continuing to optimize our code base and continue to learn how to be more effective with the limited resources that we have, that we're able to continue shipping firmware. But it really came to a breaking point in firmware 3.0 kind of time frame. So this is a number I pulled from June. Our firmware code base, when you tried to build it for a black and white watch, no voice, no color, it ended up being about 650K, which is 40% too big. Like, it's way too big. And in order for us to actually ship it on Pebble Time, we were going to have to knock this way down. And that was the challenge that was set out before us. So how do we do it? There's a bunch of different parts that go into this, and I'll go into each one of these in turn. First of all, I'm going to talk about the bootloader. So the bootloader in the firmware lives in the system flash of the chip, so you can kind of see how it's divided up there. In our Pebble products, there's about half meg of RAM, 512K, and it's split up roughly for 64K for the bootloader and 448 for the firmware. The bootloader is actually imaged onto the factory, and it never changes. And it's the very first thing that runs whenever you reset a watch or power it on. So it's responsible for booting the firmware, doing firmware updates, or booting our recovery firmware, which you're probably familiar with if your watch has ever died on you. Sorry about that. So, and the thing that we kind of realized as part of 3X on Tintin is that actually 64K is way too much. Like, this part of our system that we can't upgrade because it's the thing that does the upgrading is wasting all of this space. So in order to actually do this, actually a question, how many people have actually migrated a Pebble or a Pebble Steel to 3.0? 1, 2, 3, a few people. Do you recognize this little icon in the bottom right corner? So when this icon is showing up, this is actually our migration firmware running. So what we ended up designing is we wanted to install a firmware that you had to install to a 2X or a 1X watch in order to enable it to be upgraded to 3.x. And it does a few things. The main thing that it did is it updated the bootloader to take up less space. It also updated the PRF, so you no longer have the old 1.5 recovery firmware that we built many years ago. You have the newer graphics, the more stable kind of workflow. And it also migrated all your data for you. So the hope was that you would just connect your mobile app, you would install this migration firmware, and it would actually preserve your Bluetooth keys through this migration process so you wouldn't have to repair your phone, even when we're changing everything about how your watch works. And this is roughly what it looks like. So basically, you had a watch that still had this big fat bootloader on it. You would download this migration firmware that would boot like any other normal firmware, but it was kind of a Trojan horse in that inside of it, it also contained a new bootloader to install and a new PRF to install. And this migration ran, it showed that hourglass, and while that was going on, your bootloader was changed, your PRF was changed, and then you end up with the layout at the bottom where you boot the new PRF and we have all this extra space available for us. This is kind of a one-way thing, and it was something that was very nerve-wracking for us. We've never updated a bootloader in the field. It is the thing, it is our safety net whenever things go wrong. It's the thing that puts you into PRF when things go wrong. And it was a major challenge in order to make sure that this process was super robust and we can trust it on the hundreds of thousands of watches and users that we have out in the field. Some other details that we kind of went into. So LTO. LTO is a compiler technology called link time optimization. And what it allows you to do is it basically takes all of your code across your entire code base and rolls it up into one ball and then optimizes that entire ball all at once and allows basically your firmware to be mashed down a lot. This is kind of a newer technology. LTO is kind of rolling out into GCC and Clang in the past couple of years. It's not like everything else in the CU ecosystem and decades old, but it actually gave us a lot of space, and not quite for free. We had to do a lot of work in order to enable this, but it was another thing that we used in order to knock down the code size that we were using up. We also wrote our own standard library. So the thing that in the C ecosystems provides you your memcopy, your printfs, your basic math functions. We ended up writing this ourselves because we realized that we have different requirements from a lot of other projects out there. So we didn't care about backwards compatibility with any other platform. We just knew that, so a lot of the libcs out in the field wanted to make sure that you can run it with a program that was developed decades ago. We didn't care about that. We're doing an entirely new thing. We didn't need all that baggage. We didn't need floating point support. Heiko a couple years ago talked about code size and how to optimize your app for it, and floating point is just very expensive from a code size standpoint, and we just didn't need it. And we also just don't really care about performance all too much, except for certain very hot spots, and we can really optimize this for space and not for performance. And then unfortunately, the other thing we had to do is cut features. We had to look really hard at our feature set and say, will this be a compelling product if we cut this out? Can we still deliver a lot of value even though we're missing some of the glitz and the things that you love about Pebble? So we had to cut out the animated icons. It was sad to see them go. I love that little nuke. I love that stork that, or what is it, an ostrich that sticks his head in the ground. I miss the sloth, but unfortunately they had to be culled. We also moved back to the older style launcher. So the new launcher with the big icons, that's actually much more expensive for us to implement and get all the animations right and make it look really beautiful. So we had to switch back to the older 2X style of launcher. And also simplified a lot of the animation. So you'll notice not everything is twisting around as much, but things are more simply sliding around. And those are not because we think they're better. They're actually cheaper for us to implement. And unfortunately, the point at the bottom is that Pebble and Pebble Steel don't support health. And that's not because we hate our Pebble and Pebble Steel users. That's because that feature is actually really expensive to implement. It's so much more than the app that you access on your watch. It's actually a large code base that's dynamically analyzing all the sensors in your watch to understand when you're walking, understand when you're sleeping, and we just couldn't fit it in. There's a bunch of other work too. A lot of rewriting, a lot of refactoring, building out new technologies. I kind of listed a few of them here, but I would really like to kind of share more about what the firmware team does at Pebble going forward. And I think we're actually going to start doing a more engineering-focused blog coming up soon, where we're going to talk about some of these technologies that we're building inside the firmware code base and sharing it out with the larger world. So stay tuned for that. And then mostly, like, I'm a firmware guy, so this talk has been heavily biased about what the firmware team did, but really it was like actually a very large effort. So there's a lot of work on the mobile side to make onboarding smooth so that you can just download the app, and all of this migration process was seamless to you. All the work on the developer side, building tools that allowed people to build apps that worked across all the platforms, distribute their apps easily through the App Store, to allow them to support both of their 2x user base and their 3x user base easily. And then going through support guides, marketing it to everyone, QAing it. It was a massive effort, and really it was the first thing that we started doing as soon as we shipped Pebble and Pebble Time, or sorry, Pebble Time and Pebble Time Steel back in May. So team was probably about 6 to 12 people throughout that time, and it was a really large effort from us in order to crunch all this in. But we knew we wanted to do it, and we knew we wanted everyone to come back to this common ground. And it shipped. We made it. So the first date there is that timeline for Pebble Classic Beta, which is kind of a mouthful. Internally, we called it the 3x on Tintin Beta, where we allowed people to sign up on our Google Plus page and get early access to the firmware. Our main goal with that was to figure out the kinks in the migration process. The whole idea of updating the bootloader, changing PRF, bringing people smoothly through this really like upsetting kind of process. We really wanted to make sure it was robust, and the best way we thought we could do that is not only testing it internally, but rolling it out to a few hundred or a few thousand people outside the company. Luckily well, not luckily, but thankfully it went smoothly, and we ended up shipping it on December 15th to absolutely everyone. And if you have an old watch, it's available for you. It's our latest and greatest, and I strongly suggest you go check it out. And actually, we're going to continue doing this. So firmware 3.9 is just around the corner, and it will also support Pebble and Pebble Steel. So Pebble and Pebble Steel are brought back into the family, and we're going to continue to support them. So that's all I had today. Hopefully you understand a bit more about what went into that whole 3x on Tintin project. I hope you understand a bit more about the challenges we kind of face as a firmware team for this tiny resource-constrained device. And I hope it was interesting. Thank you. Any questions? Or you can always talk to me afterwards as well. I'll be here all night.
You've got questions. Go on, ask questions.
Yeah, the question was basically about what's on the horizon as far as compiler support as to make these kind of things easier, and what kind of things we can take advantage of to make our code smaller, make it run faster, make it easier to develop. Yeah. Yep. So I think Heiko is probably the best to answer that question as far as future language support on Pebble and how we're making it easier for developers. On the compiler side, we do keep an eye out for what kind of technologies are coming down the pipe. Unfortunately, there isn't, for a lot of these very low-level stuff, we're very much forced into kind of the C kind of environment because that's the stuff that's most applicable to the problems we're kind of solving. And we're actually kind of unique in that not a lot of other products and firmware developers and engineers in general care a lot about code size. So a lot of the times compilers are speeding up how they optimize for performance and make faster code or make it easier to write, but not size efficiency especially. So we're keeping an eye out. We're trying to push, like do a little bit of influencing to make other people care about code size, but we're trying to drive it ourselves as well and trying to build the technologies we need in order to continue to go down this path. Cool. Thank you.
Thanks, Brad. All right, and so next up we have John Barlow, who's going to talk a little bit about the health API and how you can play with it. Wes, do we have a head mic or just standing mics? Nope. All right, I'm going to help John by holding the mic then.
My pants and do this live, so.
Right, we're live demoing. It's real stuff, kids.
Okay. So I'm John Barlow. I'm on the developer relations team at Pebble. I've been with the company for 4 months now, I think. Four, yeah. And I just want to talk to you today about the health API that's just been released. It's in beta still, but I know a lot of you will be developers and you'll have watch faces or apps, and you might want to kind of integrate with this data that's now available. So what I thought I would do is take one of our Pebble example watch faces and just show you how you can easily take some data out of the health API and display it on your watch face. So the first thing you need to do in your very simple watch face is make it configurable, which goes in the app info.json file. So you'll be familiar with that already if you've ever created an app or a watch face. I'll just run through quickly some of the source code for the very simple analog watch face as it is. So we start off with an init procedure which basically loads some of the windows. We then create some text layers which are going to display the information. So on the actual watch face itself, what we're going to do is we're going to replace this date and the day name with some data from the health API. And the health API itself contains step information, so information about activity, distance traveled. It also contains sleep information, so how long you've been asleep, how long you've been in restful sleep. And then it also is exposing like the raw values that you can then work with to create your own API, if you your own algorithm, if you so want to. I'm not going to cover that today. So what we're going to do is basically just going to update this watch face to pull back some information out of the API and display it. So we'll start off with the step counter. And I'm cheating a bit. So jumping back into the app info, we'll see that the capabilities have been updated to support health. And this is really important if you're putting your app into the App Store, because of the privacy concerns around health data. Users need to know that your app is going to be utilizing that information, could do other things with that. So we expose that. That means that if the user doesn't agree to this information being used by your app, they can prevent it being installed. If you don't specify this and then you make a call to the health API, it will block your app from running on the watch. So it's really the first thing you have to do and the most important. Then back into the watch face, we've got a little variable here where we're just tracking whether health is actually available or not. This is just so you can code around if you're launching on AppLite and you're not wanting to show health information because health isn't available on the older platform. We've got in the initialization here, we're subscribing to the health events. If it's not available at that time, I'm just going to log that, but you could display a message to your users or something that they need to enable health for your app. And then we set up a handler, and in this case, we're just going to subscribe to the movement handler. But you could, sorry, this is firing the handler manually, sorry. So if we look at that handler, we're basically, was it a movement event that triggered the handler to fire, which it was. So then we're going to update our day label with the word steps. We're then going to retrieve a sum of the step count, which is an integer value that we're going to then put into our text layer. And then basically then display that on the watch. So if I build this and install it, does build, that's a start. So it needs to get access to the internet. Damn. I should have used the emulator. I'll just check the internet a second. Yeah, that's on. worked in the practice. So, right, okay, we're going to fire up an emulator then. So what you're seeing here is the word steps, and then the 0 for the step count is actually hidden behind the hand. So that's very useful. Matthew. He was the one who convinced me to do a live demo, so. Oh, it's actually my Pebble's gone to sleep. Here we go. They say don't work with like children and animals. No one ever said don't work with Pebble on live. Sorry. Here we go. Whoa. There we go. So real step count and the label there. It's partially masked, but that's real step data. So that's really simple, just getting the value from the API for the sum of today of your step count and then displaying that in a label. You can actually do way more advanced than that. You can go and query for a whole day ranges, start and end time, pull back that data and then aggregate it and do your own work with that. If I just switch over to a slightly different build. So what I've done here is I've updated the health handler slightly and changed it from being just caring about the sleep steps. It's going to display the sleep information instead. So I'll just go ahead and build that. And what I'll do is I'll make this code available on GitHub. So there we go. I slept for 6 hours and 15 minutes last night. But the type of information you've got available there, if you so wish, is like the step count, the active seconds, so that's the time. There's also a distance value there somewhere. And then the sleep seconds and the restful seconds. And all of those values can be tweaked based on a date and time range. So yeah, go and integrate that into your watch faces and apps. Any questions? It doesn't work with the classic. That's what Brad was saying about the space limitation at the moment. So. It literally came out like yesterday, so in beta. So yeah. So if you've got any questions, we're on Slack. We've got there's a documentation, there's a guides written by Chris over there for using the APIs, example apps. I'll publish this one as well. Thank you.
Thanks, John. All right, so the next person is John Garcia. Sorry? Yes. No, actually not for this one. Just leave it in. It's fine. So the next person that's going to talk is John Garcia, and he is one of my friends who actually, we met at a conference when I was working for Pebble, and he was working at Atlassian, and we together started the Pebble Meetup at Atlassian over a year ago. So he's hiding in the back room like a celebrity. Now he's going to come out and talk about his experience with Pebble. Do, 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 do. There he is. We will connect you to here.
Fun fact, if you stack a MacBook on top of a MacBook, the magnet that controls the screensaver can activate the screensaver in the other MacBook. That's what we just saw. So thanks for coming out tonight. I'm here to talk about my life with the Pebble and my experience with the Pebble. If you can't tell, I'm a huge fan of the Pebble. I've got the t-shirt, I've got the stickers, I've got the works. So the story of my involvement with Pebble probably goes about a year and a half back farther than when I met Kat, when I started working at a software firm here in San Francisco in the support engineering department. And at the time, it was right after the initial Kickstarter had launched for the Pebble. And it was the buzz all through my department. Everyone on my team and most of the people on the floor in the building were super excited about having contributed to the Kickstarter, and they were really excited about like getting the product when it did come out. I personally, I was just getting settled in the area, and I just had a child, so I didn't really have a lot of disposable income for stuff like, you know, fashion accessories or what have you. So I just kind of heard and I listened, and when they got them, I kind of peeked at them a little bit, and it was okay. It was fun. And then over time, you know, other watches came out, you know, the Android Wear series, and by then I had moved to support engineering in a different department in that same firm, and I was working with a lot of developers, and the developers, of course, they wanted to get the new hotness, if you will. But I noticed that every time I said, you know, hey, Caleb, the guy next to me, hey, Caleb, what time is it? He had to flick his wrist a few times to get it to, you know, activate the sensor to convince his watch that he had put it in front of his face to look at it, to see the screen. And it actually came to a point where that was kind of a running gag. It was kind of like, you know, I'd show up in the morning, hey, Caleb, what time is it? And so, you know, I saw this and I was like, I mean, I still had an idea that the smartwatch was a great thing to have, but I found myself unimpressed with this implementation of the technology. And then, shortly thereafter, there was an announcement by another South Bay technology firm that we all know and love. Obviously, I love, you know. And they had some words to say about their idea of a smartwatch, but just like the ones I had already seen, it had a lot of the same features. It had a really expensive screen that had to be off all the time, and because of that, the battery had negligible life. It had a touch screen like the others, which means like if your dog slobbers on it or whatever, and it gets any sort of film on the surface of the watch, you're essentially not going to be able to use it. Digital crown, that was pretty hot. I got to say, the digital crown made me happy. But overall, it really just wasn't the watch I was looking for. And so this is where Kat comes in. Next day I went to the HTML5 DevConf down here in downtown San Francisco, which was amazing. And it gave me an opportunity to see a Pebble again firsthand. But I also saw, because it was in the hands of a Pebbler, I saw the customization options and the things that you can do with the Pebble. There were all these watch bands, there were all these faces. It wasn't the same black slate that I had seen on everyone's wrist at work, right? And so I got really interested, I got really excited. I went home, talked to the wife about it, said, you know, hey, you know, it's only $90, conference special, I'm gonna pick up a watch. We decided we were gonna jump in. Well, we decided I was gonna jump in. And so I bought my watch, and it was amazing. I fell in love with it. Boy, howdy, did I fall in love with it. So I got all the watch bands that I could find on Amazon in all the colors I could find them. In fact, just about a month ago, my team lead at my new firm asked me, hey, John, do you actually match your watch band to your clothing? Yes, sir, every day. And so I enjoyed the heck out of this. The watch faces, oh, with the watch faces. And of course, watchfacegenerator.de. Whoever made that deserves a fruit basket. But then I got into more things. So I used the Dash automotive app. I don't know if anyone here is familiar. You get yourself a little Bluetooth to OBD2 connector, and you plug it into the OBD2 port in your car, and then that enables your car's engine computer to report statistics to your phone. It's kind of like, you could kind of almost think of it as Pebble Health, but for your car, right? So it records your fuel economy stats, your engine statistics, like such as engine temperature, fuel flow, airflow, stuff like that. Keeps everything healthy. Gives you the secret codes behind the check engine light if that happens to come on. And then it has some extra features. So one day, the wife and I and the child were driving home to Modesto through the Altamont Pass, which, if you're not from around here, is about 60 miles east, and it's a steep downward grade. Well, I guess it's a steep grade in both directions, but I was on the downward grade, and it's very easy to lose track of how fast you're going as you're going downhill until your watch buzzes and lets you know that you're just going a little too fast for a little too long. And so that was fun. And that's not all. It's been consistently helping me become a safer and more efficient driver ever since I got it. I don't mean for this to sound like a plug for Dash, but it's amazing, and it's a heck of a parlor trick. I'll tell you what. And so, yeah, that's been amazing. You'll have to forgive me. This is kind of a short-ish presentation. As Kat mentioned, I only had 2 weeks to prepare, which was a very busy 2 weeks. So, we are close to the end, not gonna lie. But among other things, I've been able to wire up my transit onto my watch, like my transit arrival information, so that I'll know when my bus is going to show up, and save the earth with my Pebble in another way. But then my wife, my dear wife, saw me enjoying it so much that she had to get her own. But for the year or so between me getting it and her getting hers, she was kind of making fun at me. Well, I shouldn't say making fun of me, but, persistent in the notion that she is not a watch wearer. She does not wear a watch. She won't ever wear a watch. And finally, after seeing a year of me enjoying the features and the joy of the Pebble lifestyle, she got one of her own, but she still refuses to use it as a watch. Thank you very much.
Thanks, John. That was fun. Yeah, wow, that was a while ago that we met. All right, so next up we have Heiko, and Heiko is going to talk about a new project that I'm super, super excited about, and I think that a lot of the community is going to be very excited about, especially if you know JavaScript, and if you don't, it's easy to learn. I did it. And here's Heiko. Okay, I can hold mics.
Couple of firmware people around here, please don't raise your hand, but all the others, who of you is familiar with programming in C?
If you don't work at Pebble on the firmware team.
If you're not on the firmware team, so how many? So I count 1, 2, 3, 4, 5 people maybe. And now, okay, I see that's not fair, but I mean now including everybody. Who could possibly write something in JavaScript? Yes. So JavaScript is way more approachable, and this is why we created Pebble.js. So Pebble.js allowed every JavaScript developer, for now I actually can hold it, but I need you back in a minute. Pebble.js enables JavaScript developers to write applications in JavaScript to run on Pebble, which is great. And at hackathons, people really enjoy it. And for a quick prototype, it's great. But it comes with a few really drawbacks. So one of them is, so you need to understand how it works. It runs JavaScript on the phone, and whenever you do something, say on the watch you press a button, the watch talks to the phone, hey, I pressed a button, and then the JavaScript code you wrote on the phone says, oh, you pressed a button, that's interesting. So let me say something. Maybe you should now change that text on your screen to, hey, thanks for pressing the button. And it sends that message back to the watch, and the watch then presents that. And of course, there's some latency involved. That's true. So whenever you press a button or interact with it, it takes a while until the screen refreshes. But it also means that without the phone, this app is pretty useless. And we thought, despite the fact that we are always short on code space and everything is super hard in our world, we thought, what if we could run JavaScript on the fucking watch? So I kid you not, when we talked about this at Pebble, most of these firmware engineers told us that's impossible. It's not doable. And then we did it. And it is quite possible. And after we got the resources and time to explore this more, I'm happy to tell you that we are right now trying to get Pebble JavaScript running on the watch. And the project I'm going to present is the first step towards JavaScript running there. Oh, this is awesome. Yeah, although it's a bit too high, you know. Okay, that's better. Okay, cool. So let me start with the project I want to talk about, and that is Rocky.js. So Rocky.js is not exactly JavaScript running on the watch, but as I said, it's the first step towards it. So what you can see here is basically quite the opposite. So it's running Pebble in JavaScript. And that JavaScript is running on the browser. So you see here TikTok, which is the default watch face you see on your Pebble Time or Pebble Time Steel. And it's purely running in JavaScript. So this is really in the browser. And if you don't believe me, the source code for it is written in JavaScript here. It's running directly in the browser. So what I'm doing now is, that's actually the fun part of it. I am selecting that source code, pasting it to this project here. And those of you who are familiar with Pebble programming might find the structure familiar. So you have an app info JSON, this W script, and some C code and JavaScript code. Yes, this is just a plain ordinary Pebble application, but the source code, the C source code for it, does nothing but actually calls out to the JavaScript world. So this is a firmware we have running here, and now this is not yet available on Cloud Pebble, but I'm actually building this application now in my shell to install it on my emulator. So the emulator is running here, and you see that source code over here. Let's go back to the HTML page. So you see that thing here. I'm reloading it here. I'm quitting that app, reopening that app. And as you can see, it's basically the same behavior, right? Cool. So in case you don't trust me here, let me make a few changes. But first, let me argue why this is so super freaking awesome. This is really JavaScript. And with JavaScript, you get all the toolings you're familiar with as a web developer for free. So here, for example, I'm running that in an IDE that gives me, for example, let me start that in debug mode. That gives me, for example, breakpoints. So I'm having this here. I can step through this. I can look at all the variables, make even code changes and such. But what I also gain are short turnarounds. So now let's continue here. Oops. Let's continue. I'm changing this one here to do a bit, a few more iterations on that animation. So it's going around a few more times. And now let's say, I'm also changing the background color. That's fill color, I think it's here. One of my favorite colors in our ecosystem. That's Jaeger green. So you now have this changed watch face. So that's maybe interesting and maybe impressive. But let me do one more thing. So I'm taking now the source code that runs perfectly fine in the browser, paste it back into this JavaScript world where I am rebuilding the application. And yes, of course, as we saw before, we can install it onto the emulator. But what I'm doing now is I'm installing that actually onto my watch. So that might require some setup time. So first, is that? That's the opposite direction. And then focus, please. Yeah. Ah, yeah. I know the guy who wrote it. Okay, so, and now it's always live demos, you know. Going to developer mode. So this is my IP address. I'm installing that not on QEMU, but actually on phone 172.16.0.95. And there you are. So this is now running JavaScript, the very same JavaScript we could use in the browser to quickly iterate, debug it, and all that, and the very same JavaScript runs on the watch. And although this is not the final firmware, it's a pretty good sign that it's actually possible. Okay, cool. So why did we do this Rocky thing then? Rocky will allow us to quickly iterate. So we can, for example, do this just proof of concepts for APIs and such. All what you see here, everything that's running in the browser, the transpiled firmware, all these examples are open source. It's available on GitHub, and it starts with this neat interactive code editor where we build a watch face basically. And the whole source code for this watch face is basically this piece of JavaScript. You can explore with it, but we have more examples. And even if you're not so much interested in bringing JavaScript onto the watch eventually, you can already use it to improve your C tooling, for example. Or we might use it to get a better understanding of our APIs. So recently, when we introduced new drawing calls here for the radial or draw arc, we had a hard time to explain what the different values meant. But what if you had it directly, interactively in the browser, so you could see if you pass a rectangle, how that actually influences the arc, what it means if you make the inset too large, what angles actually mean and how it affects the drawing. That's all now possible because you can leverage the existing browser technology and JavaScript technology. But equally well, because it's so accessible, the community already starts tinkering around with it, and that's actually what we are asking for at this stage. We want to know how you would use it to build your watch faces, and you can do that by looking at the output. Here, for example, we see a watch face. So yeah, so that's actually reflecting the time, mimicking a watch face that's also written or already written in C. Here, John, for example, wrote down how he would like to see a different API, something that's more convenient when it comes to watch face specific API calls. Instead of using the built-in JavaScript ability to deal with just date, what if we had something that's more convenient and tells you more about something that's important to watch faces? And we are looking exactly for that kind of feedback right now. And we are also looking for bugs. So here, right now, Rocky.js, the thing that runs in the browser, is only capable of doing our Pebble time frame buffer. So it's 144 by 168. It doesn't allow you to go round. But what if you go crazy? What if we made this JavaScript thing flexible enough to render in any arbitrary resolution, say 500 by 500? Why should we stop at physical things we have in the world right now? And we are exactly looking for that. So if you want to tinker around with JavaScript and want to contribute to what JavaScript would look like on the physical watch, please approach us, create PRs, not too many though, because we have internal bets running. And yeah, come to us here. A few of the people like Francois and me are actively working on this right now. Come approach us, ask us questions. Thanks.
Thank you, Heiko. All right, so that concludes the presentation portion of the evening. If you want to go grab another drink, we still have the taco truck for another 8 minutes. So if you want more food, they still have plenty of food. Run to the restroom, and then we'll be back in action at 8:05. All right, this is our community demo portion of the evening, and I'm going to kick it off because I have been working at Pebble for a year and a half, and I've made various watch faces, but I've actually never published a Pebble app. I've been working one for a while. Oh yeah, there we go. I've been working on an app for a while, and instead of publishing that, I decided to do something entirely different. So I have this thing called a Lockatron. I don't know if any of you are familiar with it, but it's a Wi-Fi enabled lock that you can either use on a door, or this one specifically is a relay. And so at my old apartment, it just plugged in directly to my garage door opener, and I could use either my phone or my Pebble with a super old watch app that Eric Mijakovsky wrote really long time ago with the very, very first version of Hui's Pebble.js app. So I moved into a new apartment, and turns out it's a brand new type of garage door opener that is entirely wireless, and you can't just plug things into it to control it. So my next door neighbor helped me solder this little button clicker into this relay, and it only has Ethernet. So I also had to buy this little Netgear wireless to Ethernet adapter, which a lot of people told me didn't exist. It does. And so this whole little setup is now sitting on my floor to let me either push this button manually and open my garage door, use my phone app for Lockatron, or now, fabulously, my Pebble. But the original Pebble app was only made when we only had AppLight. So black and white Pebbles, that era. I regularly use my Pebble Time Round, and last Friday when I set out to make this application work for my Pebble Time Round, I realized that turns out Pebble.js isn't available for Chalk yet. Still working on that. So Hui wonderfully gave me access to a beta of it, and I set out to create or sort of change Eric's really, really old code to work with Chalk, which is quite an undertaking. I did it though, and now I could actually open up my garage door at home, so I'm not going to do that. And instead, I'm going to wake the laptop back up and have John sign in. Please. I take this off my wrist. Yeah, so there's a simple little login page that I have already done on my watch, or sorry, on my phone. So I go in. And I'm just going to do the virtual lock for now. So it's going to ping my phone, and we have all locks. So we're going to go down to settings. We're going to add a favorite. We're going to add the virtual Lockatron so I don't actually open up my garage door and scare my roommate. And the virtual Lockatron is going to go from from locked to unlocked. We can go back to locked, and it vibrates every time. And if we want to, I think I'm just going to do it. We're just going to scare Carrie. All right. So if you're in my living room, you're going to hear this weird little tick behind you, and it's the thing on the little box. Whenever it trips its little relay, it sort of does this little tick, and then the garage door opens, which is really loud. So yeah, if you want to do this at home, just let me know. All right, and so next. All right, so since Sagir's not here, now we're going to have Keegan come up and talk about Clay. Do you want your laptop?
I need my laptop.
Okay. We'll just do it this way. Yeah, we got confirmation? Nice. So see, it worked. All right.
Hi, everyone. Okay, that's all the wrong size. That's okay. So, I'm here to talk to you about Pebble Clay. Actually, I suppose I should introduce myself. I'm Keegan. I'm on the web team at Pebble. And I'm here to talk to you about Pebble Clay. Clay is a project I started in my spare time that eventually some other employees got wind of and decided that I should do it as an actual thing from Pebble. So, what is Clay? Clay is the new auto config thing that will replace Slate. It is completely offline. It is JSON based, so you don't even need to worry about HTML or DOM or doing any kind of web nasty code that C developers hate. So yeah, no need to write HTML. You don't need to query the DOM manually when you want to load in the values, so you can submit it back to your Pebble app.js. And for the more advanced people, it is completely extensible. So you can write your own components for it, and you can do all kinds of magic with it. So who is Clay for? I kind of divide it into three types of people. The C people who really hate web servers and hate everything about the web and don't want to do anything with them, but can use JSON. So all they have to do is write a JSON file, and then Clay will magically turn it into a config page that they don't need to worry about hosting a web server for. The second group of people is for people who want to add basic interactive stuff, who know how to use JavaScript but still don't want to host a web server somewhere. And then the third type of people is people that want to do authentication or want to do some actually connected web stuff. And to enable that, I'll open source the whole thing, and then you can just like drop it in as a library that you can use. So I'm going to demo it, assuming nothing explodes. So this is the JSON file that I've got right now. And it is super zoomed in. See the point where it's unusable. So I'm just going to do that. And this JSON file, the structure is pretty simple. It's just an array of a bunch of items. And that turns into this thing. And so I've gone with option number 2 and made it slightly advanced. And what it also allows you to do is you can have a function that will run in the context of the page. So here I've added some basic interactivity where it just listens for a change on this button over here and then enables and disables your background color to go and choose that. All this is magically done and available offline, and you don't need to have a web server. So we can like live change this pretty easily. So we can say super cool. Save that, and I've got Grolp running in the background, and it goes and updates. It's still very much a work in progress. I don't have a release date for it yet. I'm taking feedback from you lovely developer people. So please, if you've got any requests for it, I'd love to hear about it. GitHub is not there yet. Once it's at a point where it's not kind of hacked together, it'll be there. You'll be the first to know. There'll be a blog post out. So if you want to feature it, please tell me. I'd love to hear about all your feature requests. I will answer one right now. It will highly unlikely be able to communicate directly to the watch to do live updates of things. It is a sandboxed environment, and we can't do two-way communication with the watch. But please, contact me. Thank you.
Thanks, Kian. All right. So I know people are hiding in the audience. If you want to come up and do a little demo, it can be 30 seconds. If you want to just come up and say something to all of us or talk about something cool you made last year, we're all ears, and I can set the camera back up again. So raise your hand. Let me know if you want to come up and say anything about any cool projects you're working on, you want to work on, you want to say something, come up here.
Hello, good to see some of the people we saw, some of the first Pebble meetups. Just want to say I love what you're doing with not just Rocky.js, but that's a great real-time debugger. Make it available now, we'll fix it for you. And we'll add more features. I'd love to be able to just test stuff right there offline. Yeah, that's good though. Web stuff is good. Especially when you can do size loading and stuff like that, testing performance. We're working on some interesting integrations with the Rocky.js stuff and what we're going to be doing with large real-time events, CrowdSync Technologies, XMP lighting stuff. And I wanted to find out if anybody's done anything with audio, if anybody's working on anything cool, and if we can assist and support that, we'd love to do it. I also help organize the Google Developer Group at San Francisco, the HTML5 meetup, and I help with the first Google Developer Group. So if you're doing anything else cool we can support, let me know. And in another life now, I'm also helping with an angel group I started. So we're doing some cool stuff. And I also work with the Shark Tank group too. So anything else people need to support things, let me know. Bye.
What was your name? Kareem? All right, nice to meet you, Kareem. Hey you, yeah? All right. All right, who else wants to come up and talk about something cool? I know you guys are all working on stuff. Jen, come up. Jen is the wife of John, who came and spoke earlier.
Hello, I'm Jen Toll. John Garcia is my handsome, my husband. It is unreal that he got me to wear a watch, can I just say, because I literally have tried more than once in my life to put a watch on my wrist, and I never failed to lose it because I could not be bothered to keep it on my wrist. But he just kept squeeing sideways like every 3 hours for a year. And I finally got one over. And the color one with the Kickstarter came out, and he was like, look, I could get you another one for like cheaper than if you wait. And I was like, fine, I will put it on my wrist and I will try it. And you'll be heartbroken if I can't keep it there, but I will do it. But he's right. I did keep the tree for a really long time, only halfway because it annoyed him. And now I am entirely addicted to the Star Trek one because it just has the right data set. So please develop accordingly. Also, when he got us the 2 new ones with the color, we gave his old one to my mother, who has been this close to losing all of her hearing for my entire life. And it has been a flat miracle for her, because I have watched through the years as the assistive technologies have gotten less sucky, because it used to be they would sell deaf people like, let's make your entire bed shake, or what if the entire room becomes strobe lighting, like how can we get you to work on time? Because alarms for deaf people, it's really hard to work out. And this thing has, I mean, it's not only miraculous that you got it to keep on my arm, but my mom, the only reason she stopped wearing it is because her latest hearing aid, they've started doing more magic with the technology with it, and it started interacting poorly. So if you guys are developers looking for needs to fill, can I please invite you to consider the hearing impaired population and what you could do to make their lives fabulous. Thank you so much.
Thank you, Jen. Awesome. All right. Would anybody else like to come up and talk about anything they've been working on, or anything they want to work on, or I have this idea, I need a developer to help me, anything like that? Going once, going twice. You just want to win a Pebble, right? All right, John, come up here. And then we'll have someone win a Pebble. Is it wrist vision related? Yeah. Sweet. I love it. I just want to make sure.
No.
Do you want to use this?
Yeah, let's try that.
John?
So, I see. So the thing requires a computer. Got it. Got it. Okay. What? Oh, the other John. Well. Yeah. Other John. Other John. Tell the watch is upside down. Oh, sorry. Oh. Hey, this is the Three Stooges do software demos here, basically. It's like, yeah. Give me that for me. Okay, so there we go. Like I said, this is just sort of a. Sorry, this is just sort of a progress report. So you can see, basically, I've got this working a little bit on the time. This is actually an old version of the SDK, so it works in interesting ways. And you have, as I say, but you can see it's giving you, I mean, fairly decent color. What I've discovered is I actually had a code in the old wrist vision, the monochrome one, that turned on the backlight, but the color accuracy goes way down. It shifts to a whole other palette basically when the backlight's on the color pebbles. So anyway, this is where it's at now, and when it's done, I'll let you know.
That's awesome. Hands-free picture taking is really useful. All right. Last call. Who else wants to show something cool? All right, I'm going to go once, twice. You can show off cool stuff next time.